With everyone going quiet at this
all
point.
Good, all good.
Right, so we're going to talk about the sky coming up and some things that we might be able to see, all being well. Oh, hang on. Oh, right, okay. There we go. And we're looking at our dear old friend, the sun here. This is the latest sun information from today, and there is a sunspot here, active region 2857. It's not very significant, but it does mean that it brings the total of spotless days up to 56. And that for this year is 24% of all days. Now compare that to last year, 57%, and the year before, 77%. That was the deepest minimum in over 100 years, 2019. So solar cycle 25 is coming up quite nicely. And there's been some sort of studies on this. This is what we're looking at here. We're going from a solar minimum with no sunspots on, and we've been through that really now. Solar cycle 25 is coming along. We're nowhere near this, but we sort of hope to get to this sort of somewhere in the next 4 or 5 years, where we get to the peak around about 2025. So the guys have been studying this. Various people have been studying sunspot cycles, and here's a look at the last few. Now we did really good. We had solar cycles 21, 22, and 23 were superb. I just moved here, actually. It's on the tail end of cycle 23, and I got some great aurora displays, including actually the first day I came to live here. I sort of realized, I heard this was on. It must have been one of you guys had talked to the radio about it, and we'd heard this, and I went up the hill behind Bangor just like 2 days before I got married, and saw a brilliant aurora. I've still got some pictures taken on film of that. And there was another one in 2005 down here, and really then that all tapered off, and we got solar cycle 24, which was not as big, but we did get some nice pictures of it's mostly around 2015 and 2016. We got good auroras from cycle 24. What they're saying about 25, there's several sort of options, and like any statistical thing, you can sort of believe any of them. The most pessimistic view is saying that solar cycle 25 will be pretty much the same as 24 was. That is to say, pretty much below average. This is the average. If solar cycle 25 was the same as the average of all the ones since 1755, it would be like this, i.e. almost as big as cycle 23. And one other study, I don't know who Macintosh et al. Were, but they seem to be saying, no, this is taking off far more than we expected. And it could go into the sort of one of the highest in the last 40 years. So we keep an eye on it, and it seems to be coming along quite nicely. We've had some good sunspots. People have seen auroras of the sort of ground hugger variety, and I'll show you what I mean by that. This was, oh, hang on, I'll go to this one first. This was October 2012, which was one of the first aurora photographs I got of cycle 24, and it was what we call a ground hugger. Here's the plough up here, and it was all below that, and it was all mostly green and not very exciting. That was taken from Ballygally, just up the coast from me here. This one was taken 3.5 years later at the peak of cycle 24. And granted, I had a better camera by then, but you can see the difference in the light. There's much more red, much more beams, just generally brighter. That's that there. And of course, the reason we're talking about this in autumn is because of this thing called the Russell-McPherron effect. And this really says that the interaction between the solar wind and the Earth's magnetic field works best around the equinoxes. That is to say, when both poles are in line with the sun. In December, the North Pole is tilted distinctly away from the sun by 23.5 degrees. And in June, it's tilted much towards the sun. Neither of those is ideal for actually getting the magnetic field to sort of funnel the particles into the atmosphere. That happens best around the equinoxes, and particularly for some reason the autumnal equinox. So that's why I'm including it here, because we hope that September, October will be good times for the first auroras, really from cycle 25. So that's the whole aurora thing. Now then, planets. It's a bit of a mixed bag, planets. We've got Jupiter and Saturn reasonably well visible at the moment. Indeed, in 2 days' time, Jupiter is at opposition. However, they're both quite low. They're both sort of around 20 degrees high at the very highest they get. Saturn actually a little bit less, because Saturn went past opposition on the 2nd of August. Mars we won't be seeing much of at all for the rest of the year, because it's pretty much on the other side of the sun. And then Venus is very low in the post-sunset sky. It's the angle of the ecliptic and the position of Venus within it is such that pretty much as soon as the sun goes down, you're looking for a very low western horizon, or a very good western horizon, to be able to see Venus at all. Mercury, we see Mercury. I'll show you that in a moment. Mercury will be a morning star in October. This apparition, again, has suffered from the same thing as Venus. It was an evening star during August, however, very low and even closer to the sun, so a very difficult spot, that one. And you can see the two ice giants, Uranus and Neptune, as well. So what I've done, I've made a little film just to guide us through where all the planets are. And this should go if I click here. So now if we set the date for Saturday, actually this is the 20th of August, and we'll set the time to the local midnight, which is approximately 1:24 with British summertime included. And we're looking directly south, and there is Jupiter, right directly south at opposition, and not far away Saturn. Thing is, neither of them are terribly high. Let's have a look at the altitude here. There's Jupiter, and down to the ground there. That's about 21, 22 degrees, something like that. So not terribly high. Let's just have a look and see if things improve as time goes on. Because let's move up to that's September, and then we'll come back a couple of hours, and we see pretty much the same picture there on the 19th of September. Except that it's 2 hours earlier in the evening, and that might mean that it's more suitable for viewing. That's actually a little bit lower there, 21 degrees, but pretty much the same. And likewise with Saturn. So Jupiter and Saturn have barely moved in relation to each other in those 2 months. If we move a little bit further, let's do that. Let's go into October. And come back another hour here. Again, it's the same picture pretty much. And as we go on into November, again, Jupiter and Saturn in the south, but now visible at about 6:30 in the evening, which is not bad. And we'll have a look there. We'll have a closer look at Jupiter while we're here. Let's just zoom in there. Okay. And there, that's in November, Jupiter, the 4 Galilean moons, and no great red spot at that point. We can probably move on through the evening, and here we are. Here comes the great red spot about 9 p.m, and I think we'll be setting shortly afterwards. Yeah, that's gone at 23. So, great red spot, very visible. There is allegedly a feature additional to the great red spot at the minute that seems to have sprouted up in the last couple of weeks or so. An extra little add-on piece to the great red spot. That's well worth looking out for too. So Jupiter, well worth a look. Now then, coming back to that local midnight sky this coming weekend, the 20th, let's go and have a look at Saturn, which is quite nearby to Jupiter. Saturn passed opposition just back at the beginning of the month, at the 2nd. And we'll have a look closer at Saturn. There we are. There is Saturn, and the rings are still nice and open, but they're not actually covering the whole planet now. There was a time when they were more open, and you would actually see the south pole of the planet obscured. That's no longer the case. There are a few moons on display. Let's find the easy one is Titan. Up to the northeast of Saturn there. but also Rhea, Dione, Enceladus, Tethys, all obtainable in a fairly small telescope with a webcam attached. You can sort of pump up the sensitivity so that Saturn is totally overexposed, and you can see some of the moons without. That's well worth looking at Saturn. And if we go back to the wider view and just see how Saturn progresses through the period. If we go right up to November, it's set by then, but we turn the time back so that it's in the sky there, and setting not long after the sun at that point, and looking probably broadly similar. Yeah, obviously the moons have moved around, but that happens quite a bit. That's sort of 17:30 in the evening, so that represents the fact that it gets dark very early on in November. So that's Saturn. Now then, Venus this time around is very poor actually. If we look at this is Friday evening, the 19th, 9:24 in the evening, shortly after sunset. See where the sun has gone down here, and Venus is very, very low. In fact, you'll need a very good clear western horizon to see that at all. In fact, I suspect you probably won't. Let's look at that in a couple of months. And there, moving ahead 2 months to October, we see that Venus is actually even closer to the horizon, if that were possible. So this is not a good time, I'm afraid, to be seeing Venus this time around. Now then, on the other side of the sky, and at the other end of the day, 7:20 in the morning, this is the 19th of October, we'll be able to see Mercury as a morning object, and let's just have a look at that. It's quite low down, but should be reasonably observable if you get the right conditions just before sunrise. That's 8 degrees above the horizon there, so should be quite easy to see that, probably with a pair of binoculars and a fairly good eastern sky. Now, in case you were wondering what happened to Mars, really the whole sort of autumn period, Mars is the other side of the sun, so not visible to us. This is where I've gone to find it here. This is the 19th of October. Again, I've gone a bit later in the day, 10:30, and Mars is right there, almost directly behind the sun. That, because of the movements of both the Earth and Mars, where the Earth is sort of catching Mars up as it goes around the sun, means also that Mars is still sort of running away from us as well. Means that really we won't see Mars at all until next year. Now then, if you haven't seen all the planets, October would probably be a good time to fill in the blanks on this one. First of all, Uranus is in Aries, and quite high up as well. That's fairly good. That's looking sort of east, southeast, east. And Uranus there is magnitude 5.65. Some people with good eyes can probably see that naked eye. I've chosen a moonless night here, more or less, the 29th of October, and we should be able to zoom in a bit on Uranus. Let's do that. And really, that's all you'll ever see, I'm afraid, in a small telescope from at least from Earth, and that's sort of the small green blob that is Uranus. We zoom closer into it, we'll see that there's 5 readily observable moons and a ring system that wasn't even discovered until 1986. So that's Uranus, and then we'll come back out from there and go along to the west a bit more and into Aquarius, where we'll find Neptune. Now, Neptune is nowhere near even as bright as... Oops, that's not it either. This is Neptune. There we go. And Neptune is magnitude 7.84, so that is not, even with the best eyes known to man, is not a naked eye object. However, binoculars, small telescope will show it as a nice blue blob, and that's all I've ever seen of it, is a nice blue blob. But zoom in closer and look at it with a more powerful telescope, and it too has rings and a few moons as well, a good number of moons, Triton being the most obvious, and probably the only one you'll ever get to see from here. But that's Neptune. So you can, having seen both ice giants and both the gas giants and all the rocky planets, then you can say you've seen all the planets, as Pluto is no longer one of them, I'm afraid. I disagree, but There's any number of views on that one, but certainly when I saw the pictures of Pluto from the New Horizons probe a few years ago, that looked pretty much like a planet with its 5 moons to me. But there we go. So that's the planets. Okay, so that's a quick trip around the planets. Other things to look out for: meteor showers. Well, we've just had the Perseids, and they technically speaking, they're probably not finished for a few days yet. I was, funny enough, the Perseids was an oddball this year. I didn't see very many at all, and indeed I read some reports from people that were saying, you know, are the Perseids dying out? And yet, on the other hand, I saw some other reports from people from different places who said, you know, they saw 150 in one night, which was quite extraordinary. So who knows? Maybe we were just, some of us looking the right way and some of us looking the wrong way. The moon was quite good to us with the Perseids this year. The next one really to come is the Draconids, 8th and 9th of October, neatly in World Space Week. And that's it's a very moderate shower, really. The zenithal hour rate, don't pay too much attention to that, but relative speaking is variable, so it can be better or worse from year to year. That's associated with dust from the tail of comets 21P, Giacoboni Zimmer, who knows, something like that. The moon there is favorable for that one. The moon is just past new and it's in World Space Week, so you might have a look out for that. First, peaking on the 21st of October and active around the 1st of October to 6th of November is the Orionids, the radiant just up above Orion. That's why that's so called. ZHR 15, so it's quite a moderate shower, really. And the moon is just past full, so let's not get too excited about that one. Then we've got the northern and southern Taurids come in October and November, respectively. And ZHR is below 5, very slow meteors. And the moon's at first quarter, which so it will set relatively early in the during the night, so we might be able to get a look at some of those. Leonids are very variable. Sometimes Leonids have good outbursts and can be, you know, quite spectacular. More normally, the ZHR is down below 15. And here's the thing about that: the moon is almost full. So even I think if we're lucky enough to get an outburst this year, it comes at pretty much the wrong sort of time, moon-wise. So that's Comet Tempel-Tuttle is the cause of that. Now then, the most spectacular meteor shower is the Geminids. It's not my favorite one. That's the Perseids, because if you're going to go out in the garden for several hours looking for these, would you rather do it in August or December? I favor the Perseids, although I wasn't terribly excited about it this year. But 14th, peaking on the 14th of December, quite a broad spectrum of time from the 3rd to 16th of December. ZHR 120 plus, so that should be a good shower. But the moon is at 9 days, so you know, there'll be a lot of stray light in the sky. It will go down sometime before dawn, and that's maybe the best time to look. There are plenty of bright meteors with the Geminids, so probably worth a look if you can get up early in the morning or stay up very late. Probably the best to do there. Now, the Ursids from the 22nd, 23rd of December. The moon is a waning gibbous at that point, so you might get some early on in the night. And it's a fairly sparse shower, though, with ZHR below 10, and it's associated with Comet 8P Tuttle. So there's a few meteor showers to look out for. Preferred technique, of course, is to lie on a sun lounger and look up in the general direction of the radiant, but looking more around it rather than at it. So that's how to do that. And of course, cameras, I'll give some advice some other time, but basically you just do time exposures, fairly short time exposures, 10 seconds or so, with a bright lens, bright wide angle lens, and you can stand a good chance of capturing some trails like that. Now let's go and have a look. I'm going to just stop sharing my screen for a moment while I just go and we'll have a look at some deep sky objects. Here we go. Well, let's start. We're starting here 1st of October, 9 o'clock in the evening, and we're looking northwest. We're looking northwest, and we find the plough. So we've got the 3 stars, the handle of the plough, the 4 of the bucket here. I always like to look. Actually, I like Meteor and Alcor. Meteor and Alcor are a naked eye double star, and it's only been found out in fairly recent years that they are actually gravitationally bound. That is to say, they are real next to each other stars, not just in the same direction. And it's a naked eye double that's quite a good test of eyesight. If you look at Meteor and you can see Alcor as well, then your eyesight's pretty good. So that's something I like to look at there. If you look closer in, actually, Meteor is itself a close double star. There we are. That's what it looks like, and I've seen that in a small telescope. Actually, my little Maksutov Cassegrain that has not much light gathering power but plenty of magnification does show Meteor as a double. That's good. There, coming back out, the more common purpose of looking at the Big Dipper or the plough is to find the 2 pointer stars on the end here and mentally measure that distance, then travel in the same direction 5 times that distance, and you will come to Polaris. And here is Polaris, the pole star. It is not the brightest star in the sky. It does, however, sit right on top of the North Celestial Pole, almost. Not quite, and I think I can show you that if there's the North Celestial Pole, there's Polaris. There is actually a little bit of a difference there. Let's go and measure how much that is, just so we know. That is... it's about just under 3/4 of a degree, the difference between the North Celestial Pole and Polaris. It's good enough for visual purposes. It's not good enough for high magnification astrophotography, where you have to sort of take that little offset into account. And there's ways of doing that, including lining up with this star Kochab, Beta Ursa Minoris here. So that's a good role that has. So let's carry on in the same general direction past Polaris, and we will come to the W of Cassiopeia just here. Here it is. There's Cassiopeia. And a few things in that general area that's worth looking at. First of all, there's just outside of that, there's the double cluster in Perseus. That's well worth looking at. Let's go and have a look at that. It shows up very nicely on film, actually, the double cluster. 2 clusters, both really related to each other. They're not just in the same direction either. So that's worth a look with binoculars or small telescope even. You'll see that it's lots and lots of stars there. There's a nice red giant between the 2 clusters. It's worth looking at. Then not far from there, now we'll go and do the navigation on this. If we find just a little bit to the west of all this, we have the great square of Pegasus. And this is Pegasus here, these 4 stars forming the great square. This star actually belongs to Andromeda up here. And what you do is look at the square, and you take the top 2 stars of the square, you memorize that distance, you come along here, and you take a slight right turn and go the same distance again until you come to a fairly bright star there called Merak. And that's Merak. And then you stop there, take a sharp right turn and go to the first star you come to, which is Mu Andromeda there. And then you go exactly the same distance again until you come to the Andromeda galaxy right there. And you can still see it with the naked eye because it is magnitude 3.4, quite visible during the autumn. And what you see is sort of the fuzzy patch in the middle there. But what you don't realize when you zoom into it, that is huge. That is, let's use my angle meter again. The Andromeda galaxy is really huge there. That's like sort of three degrees across. Depends where you define the exact beginning and end, but that's 6 moons. And that is 6 moons wide. And if it was much brighter, it'd look absolutely fantastic. in the sky, but it does need usually a long exposure photograph to show all the spiral arms and all the stars in it. And that is light from 2.5 or so million years ago. So that's the Andromeda Galaxy, well worth looking at. We'll sort of head over this direction into the Summer Triangle, because that looks great in the autumn too. The Summer Triangle is made up of these 3 stars, Deneb, Vega, and Altair. Deneb is Cygnus, Cygnus the Swan, and my favorite star in Cygnus, everybody's favorite star in Cygnus, is this one down here, Beta Cygni Albireo, which is a wonderful double star, and we'll have a look at it. I don't think Stellarium's too good at showing the colors, but you zoom into this and you see it's a binary star with one brighter gold star and one sapphire blue dimmer star. And that is a real binary star, not a same direction effect. So that's things to see there. If you're taking photographs and you've got a camera that's sensitive to red, hydrogen alpha, not all cameras are, but some do it better. Right next to Deneb here is this wonderful region of hydrogen alpha, and this part of it is called the North American Nebula. I think you can sort of see that here with Mexico and the Gulf of Mexico and Florida and Canada being very large up the top there, and also next to it the pelican. And I think you can sort of see the long beak of the pelican and its mouth there. So that's stuff to look for. So I'm going to just end that there. There's a load more to see, and we'll probably go into it in as we go through doing these guided tours over the course of the autumn. One more thing in my Colombo. I can't. Here we go. Yeah. I'm having trouble here now. I want to advance the time, and I've covered it with. Hang on a minute. I'm just going to stop this for a second. And I'm going to go here and change the time. Six o'clock in the morning. Now then, I go back to sharing. Oops. There we are. Now I've successfully changed the time. The windows sort of overlap and make things difficult. When we're into, this is the 2nd of October, actually, and we're well into it. There's 6 o'clock in the morning. Right here, you sort of get up in the morning and there is Orion in the south, looking absolutely fabulous. And it's a great time. I always make the comparison between Rigel here and Betelgeuse here. They should be, in all being well, around about the same sort of brightness, though it hasn't been the case in recent years. Betelgeuse did actually drop nearly 2 magnitudes at one stage, where it was actually no brighter than Bellatrix next to it, which is, that is, let me see, Bellatrix is 1.6. Betelgeuse is supposed to be 0.4, and they were comparable just under 2 years ago. But obviously we keep an eye on Betelgeuse. It turns out that was just dust clouds. It wasn't a precursor to a supernova explosion or anything, or at least we don't think so. So that's always a sight for sore eyes in October, because winter's not far away. So okay, I'll end that there, and if anyone's got any questions they want to ask generally, then that'd be great.